on page, I believe we left off on page 17. So have them open there. Before we get started with that, we have some questions that we need to make sure, or some things that we need you to make sure that you understand. Last time we had class, we talked about inverses, and there's 3 things that you need to make sure that you know. And then one overarching concept about inverses. Looking at what's there, the first thing that I'd ask you is this. Hands up, please, if you can tell me how you would take the inverse of a relation or a set of points. What has to happen in order to take the inverse of a relation? What do you say? So the point AB is going to become the point BA. Hands up, please, if you can tell me what you have to do in order to take the inverse of a graph. Reflect it over the diagonal y equals x. How about the third thing that we had to do, which was how to take the inverse of an equation? Hands up, please, if you can tell me how we would do that. And? What was the second part?
Solve for y.
Solve for y. In most cases, the Regents has taken it before. Technically, once you have switched the x and the y, you do have it, or you do have the inverse of the function. Now, there was something else that we talked about. Hands up, please, if you can tell me what the definition of a one-to-one function is. And this is the lazy definition. So what would the definition of a one-to-one function be? Yeah. Okay. What do we know about functions that are one-to-one? Hands up, please, if you can tell me that. Yeah. Good. Yes, every output has its unique input. Good. So if it's one-to-one, then you know that the inverse is going to be a function. Now, we'll actually come back now and we'll table this this question here. This was a calendar question from your homework from the other night. Actually, you know what? I'm sorry. We actually can't do that now. Make sure, please, that you go in and log in to your calculators. So go through and do that right now. We're going to answer the question together from the homework from last night. That's fine. With all your notes in it and stuff? Now, once everyone's gone through and logged in, here's something about, and this is what you should be doing pretty much every day. If you see that the, what's that? Turn it over and reset it on the back. If the login button is ever grayed out, turn it over. There's a reset button on the back. It'll reboot, and then you should be able to. Now, what we're going to have you all do is this. Let's log in to the calculators. And again, you should do that every time you come in. And yes, I know some of you, a lot of you have your own, and that's fine. I would leave, in all honesty, and this is just to make sure that they don't get stolen, leave them at home. Don't go through and bring them into school, because magically they grow legs quite frequently. What we're going to have you do is this. Go in. This is our home screen. We're going to start a new document. And in that document, we're going to graph out. So go in right now, please, and let's graph out this particular f of x. 2x squared plus 8x minus 7. Now, once that's in your calculator and you successfully input that, you're going to go through and hit enter, and it's going to graph. And there's a problem. Well, we need to go through and determine the question, sorry. We'll go back to this. It says graph that and use it to determine a domain over which the inverse is a function. If it's asking you about to figure out a domain over which the inverse is a function, it's asking you, where is this going to be? One-to-one. Now, there's more than one acceptable answer for this, but before we do that, you have to be smart enough to recognize you don't see enough of the graph to answer that out yet. Don't go into the table, because the table, there's situations where it's going to be a little bit awkward and you're going to misinterpret things at times. First thing up that we need to see is I need to see the full graph. I know the vertex or turning point in the graph is down here a little bit lower in quadrant 3. So if I need to lower my graph a little bit, instead of doing some mindless zoom, let's actively engage ourselves and say, if I'm trying to look a little bit lower on the graph, everything else is terrific, I just need to go a little bit lower. I'm going to have to go in and change my window. But before I even do that, what part of the window do I need to change, the Y or the X, in order to see the vertex of this graph? Hands up, please, if you can answer that. What do I need to change in order to see the turning point on this graph? Do I need to change my Y or my X? We're going to have to change Y. Am I going to have to change the Y minimum or the Y maximum? So let's go in right now. You're going to go into Menu. You can press the button. Some of you still bounce up and down with the arrow. You can go right and hit 4, which is going to alter our window. We're going to manually change the window settings. So go into 1. And we just stated the X min, X max, that's terrific. It's fine the way it is, but we need to lower the Y value. So let's bounce down to our Y min. And if we were to go through and look at this, Angel B, how low do you want this to go on the Y-axis so you see the turning point? Take a guess. If it's terrible, we'll change it. 15? Let's bounce down. Let's make it negative 15 and hit Enter. Now, it's right there. Now, see how it's just past it? Let's change this negative 15, I think, is right here or here. Let's go just a little bit lower. So go back into the window settings so we can actually see it. Let's go into the window settings, and let's change it so our Y minimum, instead of negative 15, let's make it like negative 20. So that was a really good guess. So go in and hit OK. Now we can see the minimum on that graph. If I'm looking to see the interval over which this parabola is going to be 1 to 1, I'm going to have to restrict my domain down. So I'm either going to need the left of this or the right of this, but I need to know what this coordinate is. And eyeballing it isn't good enough. So what we're going to have you all do is this. You're going to analyze the graph to figure out where the lowest point is, and the calculator can handle that. So what you're going to do is go into Menu. We need to find our lowest point, so you would go into 6. And then we need to determine, are we using a max, a min, or a 0? Well, it's the lowest point on the graph, so it's going to be a minimum. Now, what's going to come up is the part about the calculator I'm not that fond of. You have to go through, there's more than one way that you can do it, but the fastest way is this. You can activate the touch sensor by going through and rubbing your finger on the center of the touch pad, and that makes the left and right movement of that cursor much faster. You're going to go through and select a point somewhere to the left of the minimum. So this place right here is terrific. You're going to hit Enter. Now you're going to keep swiping to the right until you're past it. And then you're going to hit Enter. And what you're going to see is this. It comes up with this point. Now, you need to know how to do this later on, so we won't act like it's not an issue. If you go through and move your finger on that cursor, what we're going to do now is grab the point and drag it somewhere. Now, you've got to move it until it's looking like a claw like that. Oh. So you got to tinker around with it. Oh. All right, now grab it by hitting, pressing down on that center button. Oh. Hold it down.
You don't have to hold it.
Okay. You just hit Enter on it. There we go. Now move it up and down, and you can drag that point around so you can more clearly see it. Looking at what we've got, I need to decide where this function is going to be 1 to 1. So I'm going to either, well, there's two viable options that you all had for this. Hands up, please, if you could tell me an interval over which this function is going to be 1 to 1. Terrific. You think I'd ask you to just go through and crack into a computer here. We got 3 people. This should be hopefully very easy. Over what interval is this function 1 to 1? 1, 2, 3, 4, 5, 6. What's one of the two possible answers? No? I need an interval, yeah? Terrific. Other option? Other way around. There you go. The order on them does matter. I don't want you to get that wrong on the exam. So we could either say negative infinity to negative 2, or we could go through and say negative 2 to positive infinity. But over those windows, that's, if I view only in that region, it's going to be 1 to 1, and thus the inverse will be a function. Now, what we're doing today is this. We're working on piecewise functions. You had some experience with them, and we will caution you. Some people in previous sections were way too eager to go through and use the calculator on you. You are not a slave to this calculator, and nor is the calculator that good of a tool, and we're going to find out why. A piecewise function is a function that is defined differently over different intervals. A piecewise function is a function that can have one rule guiding the outputs in a region and then a different one guiding it in a separate region. What we're going to see is a piecewise function can bring on the same set of axes. You could be graphing an exponential. Oh, we haven't done logs yet. You can graph an exponential, a linear function, a quadratic, a cubic, a square root. It doesn't matter. Taking a look at what we have. Oh, let's go to the next page. Here's an example of a piecewise function. When we do this, I always ask that you, before you get started, you look and examine the piecewise function. So this right here is the first piece in yellow. The green is the second piece. You all at your level should be able to identify. The yellow piece is what I use when the x's are less than negative 2 or equal to negative 2. And when I graph it, the shape that that's going to take to the left of the negative 2 is going to be linear. At negative 2 to the right is a parabola. And you have a transition area. At what x do I bounce from or transition from the numerator to the denominator? Who can tell me at what x value am I transitioning from the yellow piece to the green piece? Yeah. So on your graphs, when you give these out, understand this is just an example. You would not show out these dashed lines as though this continued after the rule or the function definition here stops. Here's my guiding, or here's my divisor here. We're going to sort of, you make it sort of, there's like a little wall. To the left of it, I'm graphing a line, and that line would have continued on forever if I didn't put that restriction on it. So here is the linear piece. Here is the quadratic piece. We need to go through and determine, and that's what the graph would look like. We need to go through and determine our domain and range of this. So looking at what's there, then what would you say the domain of this graph is going to be? How about our range? Take a good look at what's there. The range is the y values that we use. So Lily, what would you say that your range is going to be? Terrific. All available y's are used. All available x's are used. Now when we do these, I'll show you how to do it and build a table. You need to be able to identify before we start, though, where this graph is going to begin transitioning. So hands up, please, if you can tell me, look at how the f of x is defined. There's two pieces there. At what x value does this begin transitioning? Hands up, please, if you can tell me. We got 1, 2. Cece, what do you say? Where am I transitioning? At what x value do I bounce from the yellow piece to the green one? So before we get started, keep that in mind, and we're going to indicate it ever so slightly on your graph, because this does not end up on the final. You would go through and just lightly include that. To the left of it, I'm graphing the yellow. To the right of it, I'm graphing the green. Who can give me an x value or an input that would mean I'm using the yellow piece of the graph? Who can tell me a number value for x that when I plug it into my function means I'm going to be using the yellow piece of the graph? -1, give me another one. -2. -2, who can give me a piece that I would be using the green graph for what input? 3? Not, sorry, yes, 2. Now, what we're going to do is this. So you should be able to recognize, first off, the transition happens at 1. And maybe we'll call it a transitional value or a critical value. So there's 2 ways that we can do this. I'll go over the easier shortcut, but when in doubt, you can always build a table. So I'm going to list out x and y. I go from here over. Now, x is less than 1, so I want to pick some values over here, and I like it going right in order, so I'll do -2, -1, 0, and 1. Now I'm going to put a little bit of a squiggly line there, something very light. And for those 4 x's, I know that those are going to give me the graph of the yellow region. So, Angela, when I plug in a -2 into that function, what output value would I get? When I plug a -1 into that function, Tammy, what output value would I get? When I plug a 0 in, Taylor?
2.
And when I plug a 1 in, I get a 3. Now, we have this great collection of points that we're going to use. Before I plot out all of these points, the transition is going to happen at 1. This is graphing the yellow. Does our graph include this point with a closed circle or not include it with an open circle at this 1? Hands up, please, if you can tell me if that value is going to be a closed circle or an open one. Why do you say closed? Good. So I'm going to plot out those points, and it's going to be -2, 0. That means you go back 2, up 0. Now again, if you can fit the points and don't show them, your graph is wrong. Fill up the space. Use a nice straight edge to help make sure you give an actual appropriate graph. Side of the calculator, whatever you choose. The next thing that we're going to do is recognize now we've transitioned into this green function. So looking at what's there, the green function is going to start at 1. So now I'm going to start listing out values here. And it's going to be, when I list this out, let's say we've got a 1, a 2, 3, 4, 5, 6, and 7. So when I do this out, now I'm going to plug the 1 into the green component. Hands up, please, when you can tell me what I would get if I plugged a 1 into the green piece. -1. What about when I plug a 2 in? Hands up, please, if you can tell me what that is. So we can see that this continues. This would be -3, -4, -5, -6, and -7. What do you mean? Oh, so what should we have stopped doing? What ones? You say them. Now, I'm going to say close. We can drop the 6 and the 7. We can't drop the 5. You go up to it with an open circle. There is something else I need to include on this graph as well. Did you object to getting? You're the one who objected to using 1? Why did you object? Tell us why you objected to using 1. So we're going to plot that point, but what's that point going to look like? Terrific. Terrific. So keep that, and notice how I put a closed circle here. This is when the table is really helpful, because you're going, okay, I'm building this up, and it reinforces that notion of, is this x included? If not, it goes up to, but not, it goes up. So we've got -1, let's see, or 1, -1. That puts me here with an open circle, and this is going to be all of these points again. Now, there's something on this graph currently that's incorrect. You can tell me what's incorrect about what's on there now. Got 3, 4, 5. What do you say? The 5 needs to be an open circle. Looking at what we have now, you have successfully built this graph. Now let's answer our questions about domain and range. So McKenna, what's the domain on this graph going to be?
Negative infinity. 1.
No. Too restrictive. How about what our range is going to be? It goes lower bound, comma, upper bound. Lauren, what would you say for the range? How low does this graph go? What gets put at the 3? Bracket or parentheses? Bracket. Does it include the value? And the answer would be yes. Now I will caution some of you. We get into, I start seeing these, right? Some sort, it almost looks like the parentheses and the bracket got together and did something that they shouldn't, and now this is what we're left with a few months later. Make sure you are very profoundly clear as to whether you're giving me a bracket or parentheses, because if I doubt it, it's not going to happen. That actually is something that rarely happens. I will correctly read it, and it's never right. So give me a nice firm, brackets meet at 90 degrees, parentheses are rounded. We can do better. Now, let's bounce. And by the way, here's one thing, though, that you've got to be able to understand, I guess, and hopefully this builds, if we discuss it now, it might make an example we do later a little bit easier. Looking at what's there, do I really need to make a table? And my argument, especially for Algebra 2 honor students, is no. I'm going on the hope and prayer that since you made it through Algebra 2, that you made it through Geometry Enriched, that you are comfortable with graphing a line in the form y equals mx plus b. Look at this right here. This yellow piece that we're graphing is nothing more than a line with a slope of 1 and a y-intercept of 2. So I could have said, all right, it would go through this point. I'm going to rise 1, run 1, put a dot, and all of these are going to be a slope of -1. I can fill that up. Now you should know what the line y equals x looks like. How about the line y equals -x? That's just the opposite diagonal, the negative of the identity function. And you'd only be graphing it. You'd say it would start here and drop down 1, except I'm not going to put a point there. I put an open circle here, and I'd stop at 5. Some of these start getting very, very quick. The table is useful at times, but at the same point, it's not the be-all and end-all. If you're stuck, always go to a table. On the Regents exam, if this were asked of you, give the table. But if we're doing an example out, build up that and reinforce those concepts that you're supposed to be good at. Let's look at the next one. I'm going to argue that for 2 out of the 3 of these, I don't need a table. I have 3 pieces here. Go through and read what's there, identify the 3 pieces, and I'm going to wait for 8 people with their hands up that can tell me where 1 out of the 2 transitioning x values is going to be. Read the indicated function. There's 3 pieces, which means we're going to have 2 transitions. Who can tell me what 1 out of the 2 transitional x values is? I have 1, 2, 3 of you. 4, 5, 6. 7. each other? Rebecca, what do you say? What's one out of the two transitioning values?
-5.
-5 is one of them. So I'm going to go through and I'm going to place my sort of very lightly done boundary line at -5.
You're going to ruin someone's life, right? Are you already very loudly?
Spencer, where is the other transitioning value? Now, as we do this, I'm going to ask you a couple of questions, because if you analyze and you get good at doing this now, it makes going forward a heck of a lot easier. There's 3 pieces on graphing. The yellow one is getting graphed over here. Do I know what this graph here is going to look like without doing a table? My answer is I sure as heck, folks. Who can tell me what that left third is going to look like when I graph it out? Look at how the function's defined in this region over here. What is that piece of our piecewise function going to look like? Go back to the function rule. What is it going to look like? Go ahead. It's a horizontal line at 4. It extends forever to the left. So if I'm graphing it out, it extends forever to the left, so it goes here and continues on. And Spencer, is this an open circle or a closed circle at the transition point? So I'd extend this out. This right here is a constant function, meaning it's constant. Which other piece should you be really, really good at graphing out of the remaining 2? Because there's one more that you should be able to. We got one person? Oh, I'm going to go. You know what I'm going to do? I'm going to go over and I'm going to rough up Mr. Welker and Mr. Scotchlater after school today. Because obviously I don't know what they were doing there, so I'm going to grab, I'm going to get on a ladder, and I'm going to grab Mr. Welker's collar, and say, what is it, teacher? Nothing. I'm outraged. Who can tell me, please, what other piece on this graph you should be able to graph? What do you got? The absolute value? I'm not going to do the absolute because it's got a transformation on it, some of you freak out. The 2x minus 1 is a line. Now, this is the part, pay attention please, this is the part where you have to make sure you understand it's a piecewise function. So if I'm graphing this is a linear graph, and we know that the slope is 2, the y-intercept is -1. So if I'm doing this, I go through and say, well, normally to graph this, I go to my y-intercept and do a rise over right. The problem is it doesn't get graphed in this area, so just put your pencil there and then go rise over right, not included. Rise over right, not included. Rise over right, this is included. Is it an open or closed circle? It's an open one to start, and then from here I go rise over right, because that's what it's going to look like for x's that are greater than 3. Now the last piece that we have to do is the middle piece. That's the absolute value. And this is going to be an absolute value shifted up too. I'm not going to risk losing so many of you. So I'm going to use a table to graph that middle piece to make sure I know really what it looks like. So what I'm going to have is this. There's my middle piece. We've got an XY chart. And when I list this out, the x's I use are the ones there, -5, -4, -3, -2, -1, 0, 1, 2, and 3. So when I plug a -5 in, I go and say the absolute value of -5. And Eva, what is the absolute value of -5? And then add 2 to that, and what do you get? Teresa, what do you get when you plug in a -4? What's the absolute value of -4?
4.
And then plus 2? There you go. Now we can keep doing this with the rest of these values. This would give me a 5, 4, 3, 2. This would then start increasing again. This would be a 3, 4, and a 5. Looking at what's there, let's ask this before we start plotting them. Is it an open circle or closed circle at the point -5, 7. Felix, what would it be? Be a closed circle. And Olivia, see, what's it going to be when I am at the point 3, 5? Is that an open circle or closed circle? Open circle. So now I'm going to finish plotting this out. I've got negative 3, 5, or sorry, 3, 5, that's open. Down, 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 and we go up, up. And did it include, yeah, negative 5, 7 is closed. So all this is the absolute value B. Now the domain, some of you are going to get this one wrong, unfortunately. Hands up, please, if you can tell me. You've got to be judicious. Be very, very careful. Hands up, please, if you can tell me what your domain would be for this function. We have 2 people. I was hoping for more. The domain is, again, the inputs that yield an output. We've got 3, 4. What do you want to say?
Negative 2, I'll take it.
Close. 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 Now, next year you're going to have Mrs. White's pre-calc enriched. I can assure you, we get into arguments all of the time. Sometimes she gets on a ladder, grabs my collar and tries to rough me up, even though I'm always 100% correct. You always need to put the union of sets when you're giving set notation. The reason being, you are indicating that there's more than one acceptable region. If you don't put it, one could interpret it as points or disconnected intervals. These intervals are connected. They're all part of the same answer. Now, how about for the range on this? Look at what's there. Sam, what do you think our range on this would be? What's the lowest value, lowest y value that this graph uses? Mm-hmm. What's the upper bound on it going to be? Does it include the 2? Now, we're talking about this right here. You're right. It doesn't include that 5. Is 5 used? It's this piece of the graph. Remember, I'm scanning. In order for it to be in the domain, or sorry, for it to be in the range, as I move this up and down. Oh, thank you. As I move this, line up and down, is it going to be hitting the graph? So as this slides up right here, it doesn't use that 4. But it uses a 4 here and here. And as I slide up here, you're right. At that value, it doesn't use the 5. But does the graph use the 5? Yes. Yes.
Oh, yeah, about the last graph, how can we...
Hang on. Are you talking about this, the previous example?
Well, both kind of.
Okay.
Why did we use the U in the second one, but not the first? If one was open, it was closed.
This right here, you use the U to indicate that you're sort of omitting that value. Now, when we're doing this out, as I move from left to right, remember, we can do the same sort of bar test that we were talking about before. Here's my line as I slide across. All of these are used. So negative infinity, all of these I'm still using here. Now, is this open, is this, what value is that? Is 1 in the domain of my graph? Yes or no? Yes. Then is like the value immediately afterwards, so 1.00001. Is that used? Yeah, it's just not used in this piece. So that's why as we continue, it's all of these values are used at some point until I get to here. And that's why it's up to 5 with the parentheses there. As we go over on this side, I could go through and do the same thing. I'm scanning, going from left to right. So as I go, all of these are used, all of these are used. It's not used here, but it is here. So that's in the domain. Now as I keep sliding this over, All of these are used, except here, neither piece is using the 3. So everything we need to jump over the 3 and keep going. Okay? Now, where did we go now? This is the piece about graphing in the calculator. We'll show you how to do it, and then we'll show you why it's wrong. This, by the way, did I show you how to make a new problem in the calculator last time, or no? Okay, so the big thing to remember on this, if you're stuck as to what to do, is that the calculator is document-based and menu-driven. Now, look up here, and you're going to be saying that in your head 100 times, because I have to say it in my head 100 times. It's document-based and menu-driven. This right here is the filing system. That should sort of indicate which question of the day you are working on. So when you finish question 1, you sort of close that up and need to move on to question 2. So it should look, when we do these out, it should go 1.1, and then we need to start a new problem, like what we're going to do now. We're going to input a piecewise function, a new one. The way to make that happen is this, and this is a shortcut. Instead of going through and going back to the menu, asking do you want to save, all of that garbage, we can get it without deleting what you've done previously. What you're going to do is you're going to get a new document without re-deleting the old one, and a new problem. So what we're going to do is press doc. So go through and do that. Oh. Hang on.
If you hit control dock, it adds a new page.
Is that what? Okay, don't hit control doc though, because that's still, think of it like this. If I'm doing my work for the day, right, I have a series of folders. Now, all of them, I need to put my work in these folders, right? This folder is going to have different work in it than this one. I don't want to put all of the work for all of the folders together. That's why we need to get a new one. So go in right now and hit doc again without hitting anything in front of it. What you need to go and do is hit 4 for insert, and we're going to insert a new problem. And what it's going to do, it has to do, you may not encounter it this year, which is fine, but we're bracing you to go forward for calculus reasons. You need to understand that the work for one problem, and when we define a variable, sometimes we need to store values. This will make it so the stuff I store in one folder doesn't bother the stuff in the other. We're going to insert a new problem. Now when you do that, notice what's different. It didn't become 1.3 or 1.4, which would be another page in the same folder. Now it's 2.1, which means it's a whole new folder. Get in the habit of doing it. It makes your work when you get to calculus a lot easier, and you're not constantly having to go back and delete things. In any case, we're going to go in and add a graph. So go in for 2, add a graph. Now, you're going to get very comfortable throughout the year. I don't know how much they use these things in Geo, nor do I know how much in Algebra 1. So we'll walk you through as though you're completely new. This button right here is going to contain all of your templates, which are sort of formulas that you're going to start filling stuff into. So you're going to select the templates button, which is here. We need to find the one out of this that looks like a big piecewise function. Our function is going to have 4 pieces on it as defined in that next example. So what you need to do is select the biggest one you can, which is this one here. And once you select that, it's going to ask you how many pieces yours has. So you're going to hit enter. It's going to say how many. Ours does not have 3. How many pieces does our example that we're going to graph have? 4. So change it to a 4. Now, when you do that, so hit enter, you get this. You're going to put the rule and then when to use it. So was the first one, was it 4 minus x?
Yes.
All right, so you're going to put that in and then go over to the right. And now you're going to put x, and then the other piece is it's got to be. Now, you don't know, maybe you know, maybe you don't. To get any sort of inequality symbol, you have to hit control equals. So press control equals, and then that pops up. You're going to go through and select the appropriate symbol and go through and finish typing the rest of this example in. So x is less than negative 2. Make sure you pay attention whether it's less than or equal to. And then fill the rest of that in. Okay. If you get stuck, raise your hand or ask somebody around you for help. They'll go through and do it. The one thing, too, to keep in mind, I cannot tell you how to use the calculator on any form of exam. So let's finish typing this in, and we'll show you and discuss why this is not correct. You're going to get a graph and it's wrong. Your homework is out of that.
Are you collecting the?
Now, once you get your graph and press enter, what I ask that you do is sometimes the function, this is going to show up here. What I need you to do is go over and grab this, and we'll drag it over to the other side. Because we want to make sure that your view of what's happening is unfettered and unblocked. So go through and hit and release that. That's terrific. Now, when I do this, you should be able to see, here's the graph. When I look at this, there's two things about this that I'm going to say are incorrect. Hands up, please, if you can tell me, based on that function, the calculator is missing two very, very important things. What's one of the two? We don't know what's happening at the transitioning values, but I can tell you that that is supposed to be an open circle. There's something else right now that's not showing up on the graph. You'd get it if you went into a table, but this is not showing up on the graph. You can tell me what else is missing from what we have there. I got 1, 2 people who can tell me. Take a look at the equation. Something is not showing that needs to be showing. 3 of us? 4? What do you want to say? That isn't actually, you said the x equals 2 line. That's only something that we would show on our graph. It's not formally shown where that transition happens. That's sort of just like the framework or the stuff that we hide.
X is less than -2. That should be open.
Yeah, those should be open. But the other one's going to come in to fill it in anyways. Mike, what were you going to say?
Arrows.
It's not going to give you the arrows. That's a fault with the calculator in general. There's one other piece that's not on there that, look at what's there. And I guess I should say what's there and what's not there. X is greater than, or x equals 6. That's here. That's that there.
Purple.
What? They don't give the third one. This is a point on the graph. Your graph should contain the point 2, -3. When I go to 2, -3, there's supposed to be a point here. And it's not there, which is why I get so frustrated when the people over at Spry are like, you just plug it in the calculator and this is what it does. Stop it. Think. That's why. You can see up on the board when you got 100, and I say it all year long. You're supposed to be smarter than plastic. Fingers crossed. Fingers crossed. I said it so many times that they put it on their brick up front. See? That's why it says it's smarter than a piece of plastic. You've got to know the calculator's there to help you, but the calculator doesn't take the place of the thinking. And the calculator is not infallible. You can go through, and if you look at the table, see that that point is in fact there. But it's not going to show you something that's so profoundly narrow. We make it huge. But in terms of what it really is, that's just a really, really, really small dot. It's not even 1 pixel's worth on the calculator. So make sure you understand its limitations. I'd advise you to finish this one independently. Let's bounce over, please, to this question for 6. We're going to go over how to write a piecewise function. And based on the work that we did previously, hopefully these are very easy. How many pieces will 6a have if you were to write it out as a piecewise function? Hands up, please, if you can tell me. How many pieces? Where's the transition value at? At -1. So I've got this, and it's going to have 2 pieces in it. There's this here, and this here. So when we're doing these questions out, I'm going to say, all right, it's an f of x is equal to, you got a big bracket here, something to the left and something to the right. I use this green piece when the x is going to be less than or equal to -1, and then I use the other piece when x is greater than -1. You need to now tell me what the equation of either of those 2 lines are. Look at the yellow line, that's probably the easier one. Who can tell me what the equation, we don't need the y equals part, of the line that's in yellow, what would that be? Look at what's there. You give it in y equals mx plus b form. Seriously, one person can tell me, two of you? Allegedly you did graphing. What do you want to say? Nope. Y equals mx plus b. Y equals x plus 2. The slope of that line is 1. The y-intercept is 2. This next one you may need to extend out just a tad when you're doing it to figure out what the equation is going to be. You can tell me what the equation of the green one would be. 1 person 2. Perfect. The slope, this right here has a slope of -1. An intercept, if we extend it out at 3, this has a slope of +1. And if we, oh, it actually goes through, it's intercept with 2. Let's bounce over, please, to the next one. How many pieces are there in 6b? Hands up if you can tell me that. How many pieces would we have? Yeah? 3. So I'm going to go through and I make note of that. Identifying the pieces is super important. 1, 2, 3. So when I list this out, my f of x is going to need to accommodate those 3 pieces. Who can tell me when I'm using the yellow piece? Who can tell me when I'm using the blue piece? Go ahead.
When x is greater than +4.
No, did I say blue? Okay, so that x is greater than +4. How about the middle green piece? When am I using that?
When x is less than or equal to -2, and
Notice, he made sure this graph is continuous. He made sure that there's going to be a closed point to fill in the other ones that were open. Now, the yellow should be easy, and so should the blue. And I'm personally hurt if we don't know the green. Who can tell me the equation of any of those pieces? We got 1 person, 2, 3. The yellow one's just going to be -2. Who can tell me another one? Function of the week. Yeah. Careful. +4. This isn't too much for you at all. Let's see. Now, there is a worksheet. Don't worry about the worksheet listed out for homework. Understand this. If I were you, I would finish up that mid-unit assessment or mid-unit checkpoint that you picked up. The answers to it are posted in Google Classroom. Next time we have class, we're going to do a little bit of review, not a full period, a little bit of review and some calculator stuff. And once we get that done, afterwards, the next class after that is your first unit exam. Now, in terms of what we're going through and doing, understand your unit exam is 50% of your grade. So, and again, please get it out of your vocabulary now, where it's like, I'm a bad test taker. If you don't feel confident, that means you need to spend some time on your review sheet. Let's make that clear. There are no test corrections ever. Okay? Again, let's imagine you're going in to have your appendix out and go, don't worry. The doctor's standing over with the scalpel. Don't you worry. I passed my medical boards every test corrections. And they put the gas on you. How would you feel? I feel pretty nervous. So go through. I think there's not many questions for homework. That's why I think that white sheet would be such an appropriate assignment for you to finish up. All right. Go through and hand those in over on the side. Make sure they're in the right spot. They don't go willy-nilly. There's a number on the back. We'll see you later, angels. Have a great day.
I've been putting it in different spots because everyone
Then take them all out and throw them on the ground. Tell me how outraged and offended you take them and throw them at other people. And say, I won't tolerate this.
Yeah,
Stephen?
Golden doodles?
Many.
Thank you so much. Thank you very much for saying that. Do this. when we get back, or once you take the exam, I want you to focus on the test. Did you get the review sheet for the test that mini? Here is, if you need some extra review, the answers to it are posted through Google Classroom, okay? Yep. And once you take the test, once the test is done, then we can go back and worry about those assessments, okay?